At the very beginnings, we are going to discuss this electromotive force, the equations and the unit and the differences between electromotive force and potential difference. What is e.m.f? E.m.f is electromotive force. Okay, this is e.m.f, electromotive force. Let's proceed to the slide. Electromotive force. Now, electromotive force is defined as the energy per unit charge. Now, per unit charge means per this unit charge. Unit charge is 1 coulomb of charge. 1 unit of charge is 1 coulomb. 1 coulombs of charge. That is 1 unit charge. So electromotive force is defined as the energy per unit charge that is converted from other forms of energy to electrical energy to move the charge across the whole circuit. So that is the definitions for electromotive force. In equations, we write E equal to W over Q. And E is the electromotive force, e.m.f. W is the energy converted from non-electrical forms to electrical forms, non-electrical energy. For example, kinetic energy, potentials energy, chemical energy. Okay, so that is a non-electrical energy and converted to electrical energy. Okay, and Q is the charge. Okay, Q is the charge. So this is the equations for electromotive force. Okay, equation for electromotive force. Up to this point, when you read this, still looks very hard to understand, right? Okay, what does this mean? What is energy per unit charge? Whereas other forms energy to electrical energy? Okay, so I'm going to explain to you later. Okay, don't worry. Okay, these definitions and this is the equations. We can use these equations to do some calculation. Usually we don't use this. Okay, we seldom use this for the calculations. Okay, but anyway, after this I'm going to explain to you what does this mean. Okay, so don't worry. And the unit of this e.m.f is joule per coulomb. Okay, or volt. And you can see that this is the same unit that we use for voltage or potential difference. 1 volt means 1 joules of electrical energy supplied to the circuit to move 1 coulombs of charge across the whole circuit. Okay, I'm going to explain to you later as well, this one. Okay, so don't worry about this. Okay, now let's see what does this means. Okay, what does the e.m.f means? From here we can see that there is a circuit here. Okay, there is a circuit. Let's say from here we can see that we have a circuit and there is a source of energy. This is cell, dry cell, and we know that for dry cell the energy convert from chemical energy. Inside dry cell we have this chemical energy, and the energy is converted from chemical energy to electrical energy. So that is from other form of energy, other form of energy to electrical energy. Okay, so here the labels tell us that the e.m.f, the electromotive force, is equal to 10 volt. Okay, 10 volt. So what does this mean? What does this mean? We have e.m.f 10 volt. So what does this mean? Okay, it means 10 volts. It means 10 joules of chemical energy converted to electrical energy. And the energy supplied to the circuits to bring 1 coulombs of charge across the whole circuit. That is what does it mean by e.m.f 10 volts. If you see e.m.f 10 volts, it means that if you move 1 coulombs of charge, across the circuit, 10 joules of chemical energy, I think I should write here, okay? So 10 joules of chemical energy will convert to 10 joules of electrical energy, and this electrical energy is used to move this 1 coulombs of charge across the whole circuit. Now 10 joule is for 1 coulomb only, okay, 1 coulomb. Let's say if you want to move 2 coulomb, then you need 20 joule. If you want to move 3 coulomb, then you need 30 joule. Okay, that is what does it mean by e.m.f 10 volts. e.m.f 10 volt means that every 1 coulomb of charge move across the whole circuit from the beginning to the end, we do 10 joules of work. And the more work is done, the faster the charge move. Okay, if we have 20 volt, means that if we can move the charge, move faster. If you have a 30 volt, then it moves even faster. So this energy is related to how fast the charge move. The more energy, the faster the charge move. And the faster the charge move, the higher the current. Okay, current is a measure of how fast the charge move. So that is what does it mean by EMF. That's how much energy supplied to the circuit to move 1 coulomb of charge. We can also see that here, there's a wattmeter, and the wattmeter give a reading 2.5 watt. 2.5 watt. Now what does this mean? EMF 10 watt means that 10 joules of energy give to the circuit to move 1 coulomb of charge. So 2.5 watt of potential difference, what does it mean? We have learned potential difference in previous lessons. So 2.5 watt means that it's still 1 coulomb, okay? Means that 2.5 joule of energy is needed to move this 1 coulomb of charge from this point to this point. Okay, EMF is for the whole circuit. Okay, potential difference is only for 2 points, from this point to this point. If you move this 1 coulomb of charge from this point to this point, you need to do 2.5 joules of work. When we move this charge from this point to this point, okay, the electrical energy will convert to heat energy in this resistor. Okay, so for potential difference, there's a change of energy or conversions of energy from electrical to other forms of energy. For EMF, it converts other forms of energy to electrical, but potential difference is from electrical to other forms of energy. We give 10 joule to the circuit. We use 2.5 joule to move the 1 coulomb of charge from this point to this point. Okay, from here to here, no work done because there's no resistance. Here, 7.5 watt means that we need to do 7.5 joules of work to move this 1 coulomb of charge from this point to this point. That is potential difference. That's potential difference. So we say the potential difference 2.5 watt means that work is done to convert 2.5 joules of electrical energy into heat energy to move 1 coulomb of charge across the resistor. Okay, this is 1 ohm and this is 3 ohm, so 25%, because this is 25% of the load resistance, so 25% of the energy used here. 25% of the energy supplied by the cell is used to move the charge across the resistor. Why 25? Because this is 25% of the load resistance. 1 ohm, 3 ohm, together 4 ohm, right? 4 ohm. So 4, this is 1 over 4. 1 over 4 means 25%. 25%. This is 3 over 4. This is 75%. That's the meanings of potential difference 2.5 watt. That's how much work done to move 1 coulomb of charge across these 2 points. Then how about this one? This one, the potential difference 7.5 watt. So it means work is done to convert 7.5 joules of electrical energy into heat energy to move 1 coulomb of charge across the resistor. And this is 3 ohm. 3 ohm means 3/4 of the load resistance. So therefore, it's a 75% of the energy supplied by the cell to use to move the charge across this resistor. So that is the meanings of EMF and potential difference. EMF is how much energy you give to the circuit to move the charge. Okay, for the whole circuit, and it converts from chemical energy to other forms of energy to electrical energy. Potential difference is just from one point to another point. How much energy or how much work done to move the charge from one point to another point. Okay, that's the difference between EMF and potential difference. Let's go back to the differences between electromotive force and potential difference. Okay, differences and similarities actually. Okay, so EMF and the potential difference, the similarities, both of them have the same unit, watt. Okay, so electromotive force is measured in watt, potential difference is also measured in watt, and both of them is measured by using watt meter. By definitions, electromotive force is defined as the energy per unit charge. This one is also per unit charge. Even though you write 1 coulombs of charge, this is 1 unit charge. Okay, and this is also per unit charge. Okay, so that is per unit charge that is converted from chemical, mechanical, or other forms of energy to electrical energy in batteries or dynamo. Okay, this is a source of electrical energy, batteries or dynamo. Okay, and the symbol used for EMF is this capital letter E. That's the difference between electromotive force and potential difference. Potential difference, we use the symbol V. EMF, we use the symbol E. The definition for potential difference, the potential difference between 2 points. Okay, this is just 2 points. This is for the whole circuit. For the whole circuit, this is just 2 points. It's defined as the energy converted from electrical to other forms. This other forms to electricals. Other forms to electrical. This is electricals to other forms. To move 1 units of charge. Not necessarily it must be positive charge. Okay, you can cancel this positive. Okay, cancel the positive. So it's when 1 coulombs of charge passes between the 2 points. So that is the difference between electromotive force and potential difference. Okay, the symbols are different. This is the energy supplied to the circuit is from other forms of energy to electrical energy. This is from electrical energy to other forms of energy. Okay, to move 1 coulombs of charge. This is just 2 points. This is for the whole circuit.